Well, folks, this is the third way of actually being able to change all of this. Now, forgive me, but I think it was actually, this should be lesson 3. Shouldn't it be lesson 3? That's because I actually came through and I was changing a lot of different things. So can we cross out lesson 4 and make it lesson 3? Sorry about this. I used to teach the infinite solution and no solutions in a totally separate lesson at the end of this chapter. And I was like, nah, you guys can handle it. And you have. You've handled it quite well. Well, this is used for the situation where both equations are in the same form. And most of the time, we say, hey, it's in standard form. That lends itself to a perfect elimination method setup. The basic idea is that we need to add the two equations together, and it gets rid of one of the letters. You'll either get rid of the x's when you add them, or you'll get rid of the y's. Okay? And once you're able to get rid of one of those letters, then you're able to go solve for the remaining letter. That's kind of like substitution method, isn't it? We would substitute a letter in for another letter. So instead of having an x and a y in the equation, suddenly you're looking at an x and an x. Does that sound about right? Well, that's what's going to happen here. Look how easy that this goes, though. Could you guys just come straight down here, put a little plus sign here, draw a line? We're going to add these two equations together. What is the negative 2x plus positive 4x? What's negative 2 plus 4x? So I'm going to write 2x right underneath it. Now over here, I'm going to do the next one, the y's. I'm going to do those in green. If you don't see a number in front of the y, it's really a what? Hey guys, what's 1 plus negative 1? So it cancels. And then I'm going to come over here and do the last one in black. That's 3 plus 5. I think you guys can solve for x, can you not? So that's what I want you to do. Then we'd be like, hey, divide by 2, divide by 2. X equals what? Sweet. We've got half of our solution. Do we like this method? Love this method. We're going to go back and look at how that affects our story problems that you did last night on 1314. Remember, I had you build them. Turned out it was standard form equations. How can we actually go and get the second part of our answer? Well, do you remember how we said on substitution method, you then go and plug in your x value or the first value that you found back into one of the equations? It didn't matter which one. Usually for substitution, we went for the shortest one because it was so easy. Do we have two equations that we can choose from here? Yeah. Which one seems easier to you guys? I'm going to erase this just for a second right here. Is that okay? Can I erase that? There we go. Do you want to use the negative 2x equation or the 4x equation? It does not matter. Which one? Do you want the 4? I like the 4 also. The minus is a little weird, but at the same time, the negative 2x has got the negative. So, I mean, it really doesn't matter. So, but you said 4, so let's go and use the 4. So now I'm going to write 4. Let me switch the pen here. I'm going to write 4x minus y equals 5. And then I'm just going to show that we took that x equals 4 and we're going to plug it right into that x. Okay? So the 4 is multiplying the x, and that means that this 4 right here should be multiplying the blue 4. Do you see that now that we've substituted a value in for x, we can actually go solve for the y, which is what we need. And we follow the regular way of solving. 4 times 4 is 16. What would you guys do now? I've got to get that y by itself. What would you do? Minus 16. Minus 16. The negative y can fall down, and we get negative 11. Question. Am I happy with that negative sign in front of the y? I'm not happy at all. It's really like there's a negative 1 that's multiplying it. So now we can just divide by both sides, negative 1. And I get y equals positive 11. Now, how can you go and check to see if you've got this right? you can go to both equations, not just one, both equations, plug in the 4 for x, plug in the 11 for y, and see if it makes both equations what? True. That's all it is. Could you all go and use this skill right now for that second system of equations that we have over there? Just add them up, go find your first letter, plug it back in to go find your second letter. Okay, so can we go ahead and slide a 1 in front of that x right there? Yeah, and technically you can slide the 1s in front of the y's. It will actually, for elimination methods, sometimes it helps you to be able to see that early on. Now let's go put a little bit of color just so I can direct your focus. What's 1 plus 2? 3. They both have x's, so that's got a 3 on there. Let's go green. What's positive 1 plus negative 1? 0. And we don't put 0y. We just put what? Nothing. Okay, they canceled. Now, it's not always going to be your y's that cancel. Sometimes your x's will cancel. Are we clear on that? We don't care what cancels as long as one of the letters goes away. As long as one of the letters goes away, we have success, and then we can go solve for our other one. Now, what do we have right over here at the very end? 7 plus 2 is 9. So how do we go and solve? Divide by 3, divide by 3. X equals what? 3. Kind of anticlimactic there. So now I'm going to go and erase this just so we can see it. I think I have a very clear equation that I think I would like to use, but it does not matter which equation I choose at this point. Do we want to use the first one or the second one? Which looks easier? I love the first one. I love the first one. You want to know why? Because I can almost do that in my head. In fact, you probably could. Look, x plus y equals what? 7. 3 plus y equals what? 7. You could 3 plus what equals 7, guys? 4. But I mean, look, if you want to see, look, it's right there. Y equals what? 4. Now, if you don't mind, I would like to just for a second here. That's the notes I would like you to have right here. Is probably that one. But I want to prove to you that it really does not matter which equation we use. Look, 2x minus y equals what? 2. What does the x become? 3. And we're supposed to get a 4 for y, correct? So let's go make sure that we get y as 4 again. 2 times 3 minus y equals 2. 2 times 3 is 6. Minus 6, we get what? Negative y equals negative 4. Pop in the what? Do we still get 4? So it does not matter which equation we plug it into. What you want to do is you just want to find the easy one. Okay? So after all of that, though, I would be, actually I'm requiring, you have to put in your x and y as an ordered pair. You got to put the parentheses around it. Now, I think this is a good spot to stop here on Friday for the lesson. I don't want to start breaking your mind in little pieces right before I send you home. But I do want to draw your attention to this. Sometimes you'll need to change the equation. Don't write this one down. This is further on your notes. Do you see I would get 3x here, and what would I get with my y's? 5y equals what? 13. So what I've got to teach you to do is I've got to teach you to be able to change either one equation or two equations, so that way when you add them, it'll knock out one of your letters. Once I teach you that, the sky will be the limit. If you go back and you look at last night's homework, do you see that we have two equations right here that are set up in standard form? Well, then I'd be able to go use the elimination method to go solve, and it's a lot easier than using substitution when your equations are set up in that standard form, when they're in the exact same format. Technically, you can use this for substitution methods where they're both in slope-intercept, but there's an easier way that we'll get to that. Okay? So, are you guys ready to jump in and try the beginning levels of elimination method? All right, then I'll end the lesson right here for today, and we'll pick up lesson 4 on Monday after we check your homework.